Hello and welcome back. So we're going to continue our discussion on using polars and double integrals to find areas and volumes. Now this question right here is definitely a volume question because we have a little function in here times my area. So it's like my z function, my height times my area of my base, so it's going to give us a volume. Now the region that we're looking at, D here, is the portion of the region between two circles, one radius 2, one radius 5, centered at the origin in the first quadrant. Now, because we're in the first quadrant, that is kind of telling us our theta. Our change in theta goes from 0 to pi over 2. So if I look at that region, we can look at this region right here. It's between radius 2 and radius 5. And we're looking at this little portion right here. So I can get my base region, which is going to give me my base right here. So looking at this part now, remember, we're going to take this right now and we're going to project this up. So this is the area of my base, and we're going to project this up to this function, and that's going to give us our volume right there. So remember, this is the part that's being projected to the function, and that's going to give us our volume right here. So we're going to look for the area of the base. So to get the area of the base, we're going to choose to use polars because we're using circles. So to do polars, I need my change in radius, which isn't that bad to do. My radius is only going to go from 2 to 5. I'm only worried about the part from 2 to 5. My change in theta, well, that's going to go from 0 to pi over 2, because I'm only interested in the first quadrant right there. And now I can go and write out my integral. My double integral. Remember, I'm going to have something right here. I don't know what yet. I don't know what's going to be right there just yet. But I know because my dA here in polars is r dr d theta. So we get this r dr d theta. But I do have to convert my function 2xy into polar. So we're going to have to change 2xy into a polar. And I can do that. This becomes 2r cosine theta r sine theta, or 2r squared cosine theta sine theta. Right there. And now my domains, my change in radius goes from 2 to 5, my change in theta from 0 to pi over 2. So there's my integral, and this is going to find us our area. All right, so let's take a look here. If I rewrite this right here, if I rewrite this one as r times r squared, I can write this as 0 to pi over 2, 2 to 5, that's what we're looking to, and this becomes 2r cubed cosine theta sine theta dr d theta. Don't forget that r right there. Always tack it onto another r if you have it. This way you don't forget about it. And now when I integrate, I'm first going to integrate with respect to r. And integrating with respect to r, that's going to give us 1/2 r to the 4th cosine theta sine theta. And we evaluate that from 2 to 5. Now we're only plugging these in for r. So this becomes 625 over 2 cosine theta sine theta minus 16 over 2 cosine theta sine theta, which becomes, this is really long, 609 over 2 cosine theta sine theta. And this is what I want to integrate. The 609 over 2 is a constant. I'm going to leave that to the outside. 0 to pi over 2 d theta now. And I'm going to use u substitution. Oops, excuse me. I'm going to use u substitution. I'm going to let u equal sine theta because its derivative is cosine theta. Those cancel out. This becomes u squared over 2. So we're left with 609 over 2 times sine squared theta over 2 from 0 to pi over 2. And when you simplify all of this, what you're going to wind up with is 609 over 4. And that's easy enough to do because sine of pi over 2 is 1. Square that is 1, so I just get 609 over 4. Sine of 0 is 0. So there's our final answer. Don't forget u substitution. If you forgot that, watch another video. All right, for number 2 here, let's take a look at number 2. Hopefully I have enough room here. Now we want to find the area, the volume here, where our region is the unit circle centered at the origin. And the unit circle, they do give us the radius. The radius, of course, is 1. So if I draw out my base, because it's all about the base, no trouble here. My radius, for my base now, my change in radius is going to go from 0 to 1. My change in theta, that's going to go from 0 to 2 pi. Next, I have to convert. So I'm going to take this e to the x squared plus y squared. I'm going to convert that. Oh, that's not too hard. What is x squared plus y squared? Oh yeah, r squared. There, I converted to polars. That's one of our polar conversions right there. So when I write out my volume equation now, we're going to get our double integral, my function, e to the r squared, r dr d theta. Please don't forget that r. That's the one thing you're going to want to forget. My change in radius, 0 to 1. Change in theta, 0 to 2 pi. And when I integrate with respect to r, I can use u substitution. My u is r squared. So so my integral here is just going to become 1/2 e to the r squared from 0 to 1. And that's just 1/2 e minus 1/2. And that I'm going to integrate now. 1/2 e minus 1/2 d theta from 0 to 2 pi. So when I integrate with respect to theta, we get 1/2 e minus 1/2 times theta from 0 to 2 pi. And I just worry about the 0 there. We don't worry about that one. We get 1/2 e minus 1/2 all times 2 pi. And you can, whoa, hello, where'd it go? And you can simplify that if you like. These aren't hard to do. The only thing you don't want to forget, that r. You don't want to forget to convert. You want to convert your x and y's into r's and thetas. And we know from polars, x squared plus y squared is r squared. That's our unit test from our circles. All right, so for the last one, we're just going to set this one up, okay? All right. Determine the volume of the region that lies underneath this sphere. So we're looking for a volume here underneath this sphere and above this plane. So this is my top and this is the bottom. So you can kind of think about what this looks like right here. We have this sphere, right? And we want to find the volume above the xy axis, xy plane. So we want to find the volume, but not that we don't want to find that volume. We're going to restrict the inside of the volume by this cylinder. So now we're going to have this cylinder come up. Let me go and do a different color here. Now we're going to have this cylinder coming up like so. And we want to find the volume inside the cylinder. I know that's kind of messy. So that's why I hate drawing in 3D. So I'm going to go ahead and use my normal two-dimensional graphs. So let's see here. I'm going to draw my base. This is going to be my base right here. That's because that's on the xy plane. If I draw this, it has a radius of the square root of 5. So for my base, my change in radius is going to go from 0 to the square root of 5. My change in theta is going to go from 0, and it's going to go all the way around to 2 pi. Now, so right now, what I'm looking at for my double integral for my volume, now you got to be careful. We are in polars. So these are not in polar functions right now. So before I do my volume, let me scratch this out here. Before we do our volume, we should probably convert these into polars. So to do this one, I'm going to solve for z. Z would equal the square root of 9 minus x squared minus y squared. Now notice, I am keeping it positive because I want the top part. To convert this, recall x squared plus y squared is r squared. So therefore, I could write z as the square root of 9 minus r squared right here. The bottom is just z equals 0 still. So when I think about my top and bottom, I'm going to take my top function minus my bottom function. So when I write out my volume equation, I'm going to take my top function, which is the square root of 9 minus r squared, minus my bottom, which is 0. r dr d theta. Don't forget that r right there. And now my change in r, 0 to the square root of 5, 0 to 2 pi, and this I can solve. If I get rid of that little 0 right there, it's not too bad to look at. 0 to 2 pi, 0 to the square root of 5. Put this r in the front. That is a variable. It's not one of my changes. It's a variable. I can just put that out to the front. 9 minus r squared dr d theta, and now that's just use substitution right there. You can solve that. I hope you guys enjoyed these videos. I will see you soon. Bye bye.